Hello everybody. Today's topic is complex mechanics, day one. We're going to be doing this for a couple of days, or rather not days, but a couple of work sessions. The reason why this is called complex mechanics is not because it's complex as in hard or difficult. Ironically, the first example we're going to do is going to look very difficult. I promise that the second example is going to be way easier, but they're both complex mechanics. So I guess maybe first we should go into what complex mechanics means. Without going through the front page, we'll save that until after. Why don't you look at this question for a second? The back page, or the back of the first page, there's a skyscraper. And in this question, there's an elevator that leaves the bottom of the building and it begins traveling upwards at a constant speed. At some time later, 15 seconds later, you, up on the roof, drop a water balloon. That's a totally different object. That's free falling with gravitation, so it's getting faster and faster and faster as it falls, whereas the elevator is just lazily climbing at a constant speed. And the question is, where will they pass each other? That's what makes it complex, is you've got more than one object in one question, and their motion is somehow related to each other, in this case because of the height of the building, and you have to try and figure out an answer to some unknown part of the problem. If you try to make a givens list for one of these objects, in fact, I'm going to do that on a separate piece of paper, even though it's written on your page. If I try and make a givens list for the balloon, we're immediately going to run into a slight problem. Now, the first thing I want you to do is pause this video and read example number 1. So please do that first. Go ahead. Okay, you're back. The balloon is dropped from the top of the building from rest. So if you tried to make a givens list for the balloon, V1 is 0. No problem. And it free falls. So the acceleration of the balloon is 9.8 meters per second squared. But you run into a problem when you try and fill in the final speed. That's the final speed when it passes the elevator or when it hits the elevator. We don't know what that is. I mean, there's nothing in the question that even remotely indicates what that speed is. Distance. It does mention in the question 300 meters, so there is a distance given, but that 300 meters is the entire height of the building. This is just the distance that the balloon drops when it meets the elevator. We don't know that. It definitely has to be less than 300 meters, but we don't know what that distance is. Time. Time is how long the balloon falls for. And I know the question mentions 15 seconds, but that's not the time that the balloon falls for. That's actually the amount of time the elevator rises before the balloon is even released. So we don't know that time. So you have a problem with the balloon, because I always told you in grade 11 to do a calculation using a physics formula, you need, in acceleration formulas, you need to have 3 givens in order to calculate anything else. So the balloon's givens list is not going to help us in the beginning. Let's switch over and look at the elevator's givens list. This is a constant speed object, so the list is going to be a lot easier and a lot shorter. It's not V1 and V2, there's no acceleration. The question says that the elevator rises at a speed of 6 meters a second, so we do know the constant speed. The distance, you don't know what it is though. The skyscraper is 300 meters high, but the elevator doesn't go all the way to the top. So the distance the elevator rises when it meets the balloon is an unknown. The time that the elevator rises, at first it sounds like we can use 15 seconds, but be careful. We want to know how much time the elevator rises before it meets the balloon, and the 15 seconds is not that time. That's the time that it rises before the balloon is even released. So we actually don't know the time for the elevator. Well, there's a problem, because we've got 2 givens lists and absolutely no way to start the question. There's always something that you're solving for though. So read the question. The very last sentence says, at what vertical height will the water balloon pass the elevator? You can translate that a little bit. Maybe I should have typed it differently. What that means is, how high is the elevator going to rise? How high off the ground will the elevator rise before the balloon passes? So the distance that the elevator rises is what we're going to solve for in this entire question. Make that x. That's what we're going to solve for. And whatever you make as x, whatever is going to be your unknown, in the other formula, in the other givens list, you can write something that corresponds to that x. Now here's where you have to be smart. Here's where you have to really think about what you're doing. We don't know how far the balloon's going to fall, but if I sketch a little quick diagram here just in the middle, a little junk diagram for you, if the elevator rises distance x, we don't know what the distance is that the balloon falls, but we do know that it has to be 300 minus x, because the height of the building is 300. So whatever the elevator rises, the balloon has to fall the rest of the way. So the 300 detail wasn't a frivolous detail. The distance that the balloon's going to fall is going to be 300 minus x. And really think about that. Okay. Wherever you put the unknown variable that you're trying to solve for, that's where you're going to put another unknown variable. So let's look at the time for the elevator. We don't know how long the elevator rises for, but we do know that there's a 15-second difference between the length of time that these objects are going to be in motion. So I'm going to make the elevator's time an unknown value. I'm just going to use y, simply because it comes after x in the alphabet. So if the elevator's time that it rises is going to be y number of seconds long, how long is the balloon going to be in motion for? Now this one's tricky. Time is always the tricky part that you really need to think about. There's a 15-second time delay in this question. The elevator rises, and 15 seconds later, the balloon is released. So does that mean the balloon is in motion 15 seconds more than the elevator? Or does that mean that the balloon is in motion 15 seconds less than the elevator? It's less. The elevator's in motion for 15 seconds, then the balloon is released. So the balloon's time would be y, but it's y minus 15. It's 15 seconds less than the elevator. Does this make sense, what I've kind of written in a little bit more boldface? Maybe this here. The first time through, it's not going to make that much sense, but you have to practice this. This is just one example. The whole point is, by filling in an unknown variable for both the distance and the time, even though we don't know what the balloon's corresponding answer is, it's related. The building's 300 meters high, so there's a relation between the distances. And there's a 15-second waiting period that is a relation between the two times. So that's what you're searching for, is the relations. What does all this mean? Why is this even on here? You can write a physics formula for each one of these objects. The elevator is the easiest because it's constant speed. D equals VT. If you write down D equals VT for the elevator and you fill in the givens, distance is x, v is the speed of the elevator, 6. And one thing I'll say, we never use units when you're doing complex mechanics. Stick just to the math. No units. Time is y, t is y. There's a formula. It's a nice, short, easy formula. I'm going to call it formula number 1. Maybe I'll call it formula number 2 since it's the second object. That's a nice formula, but you can't solve. X equals 6y. You can't solve for x, you can't solve for y. It's one formula with two unknowns. Impossible to solve it. But the nice thing is you have another object. And you have another object that's going to have another formula. And that formula is going to have the same x and the same y in it. You can always solve two equations, two unknowns. So that's the point of these questions. You want to design two equations that have the same two unknowns. Let's look at the balloon. Unfortunately, the balloon's going to be a little bit more complicated just because with no V2, the formula that matches these variables is an acceleration formula. D equals v1t plus 1/2 at squared. And I promise the second example is going to be a lot easier than this one. The problem with this formula is t ends up getting squared. And if you look at t, it's a, I forget what you call that in math class, not a binomial. Is it a binomial? I forget. But let's fill in the givens. And you just fill them in exactly the way they appear. If it looks like it's going to be hard or complicated, who cares? They're just numbers. D is 300 minus x. V1 is 0. T is y minus 15. Plus 1/2. A is 9.8. T squared. Here's the only part that's going to suck a little bit in this question. T is y minus 15. And unfortunately, you have to square it. It's probably been a while since you squared a set of brackets like that. It's a grade 9 and 10 math skill, but it's probably been a while since you did it. So make sure you square those right. Actually, I'm going to do that first. Make sure you don't call that y squared plus 225. That's y squared minus 30y plus 225. Actually, let's just write this out backwards. 1/2 of 9.8 is 4.9 in front of those brackets. This whole term is going to be 0, so actually I'm not even concerned about that. 0 times all that is 0. And the left-hand side of this is still 300 minus x. It's not immediately necessary to FOIL this through, but you know what, I'm just going to clean it up anyway. I think things work out nicer if you do math to them and clean them up a little better. So I'll do one more line. 300 minus x equals 4.9 y squared minus, gotta get the calculator out for this one, 4.9 multiplied by 30 is 147 even. Y. And 225 multiplied by 4.9 is a very specific 1,102.5. Again, if you're looking at this and you're starting to get worried, what are you worried for? It's just numbers. You know how to do all this math. There's another equation. It's a bit longer than I would have liked for another equation. This is equation 1 because it's object number 1. What you have on the page, if you look in the rectangles here, you have 2 equations, 2 unknowns. And you should know from math class, no matter how scary the equations look, if it's 2 equations, 2 unknowns, you can always solve. You just need to substitute one equation into the other. And one of the equations will look easy. In this case, it's even already isolated. X equals 6y. So what I'm going to do is, I'm going to take this value for x and I'm going to substitute it in to formula number 1. That will eliminate the 2 unknowns. Just like the pre-math skill question that I had you do before watching this video. 300 minus, not x, but the substitution. 300 minus 6y equals 4.9y squared. Sorry, I know this is tedious, but I want to write out every single line because you'll be able to follow it easier. All right, that's one equation with one unknown in it. You can solve that. Unfortunately, there's a y squared and a y, so we're going to have to use quadratic formula. Now, I promise you don't always have to use quadratic formula. Example number 2 is going to be way easier than this. But if you have to use quadratic, you have to use quadratic. You're grade 12s now. If you have to use quadratic, you just do it. You stop worrying about it, and you just do it. Quadratic is a lot easier if you push everything to one side and put it in the proper order. So I'm going to move everything to one side and make the left-hand side 0. Okay? So, move the 300 over, move the negative 6 over. Maybe I'll write out what I already had here first. So 4.9y squared minus 147y plus 1,102.5. And now bring these over. Negative 300, because the sign's going to change, and positive 6y. collect like terms. To make things a little easier here, 0 is going to equal 4.9y squared. Then we'll collect together the y's, so minus 141y plus 1,100 and, oh, sorry, there's a 1,102.5 and a negative 300. So collect those together, and you're going to have 1,102.5 minus 300. I almost wrote that wrong. 802.5. So there's your A term, your B term with the negative sign, and your C term for quadratic formula. Now, listen, grade 12, get a quadratic formula calculator. Quadratic formula is gonna pop up throughout this course when you least expect it. It happens all over the place. Get a quadratic formula calculator or get a cell phone app that does quadratic. I am sitting right here beside a computer, so I'm gonna go to a quadratic formula website. I do this all the time, and if you're sitting at home working, definitely use a quadratic formula calculator. Don't try and do it manually. There's no marks for it. You have to get it right, but you don't have to show your work in grade 12. So 4.9 minus 141 is my B term, and my C term is 802.5. Calculate answers. Okay, so we have two possible answers here. That's for a reason that I'm not going to get into right now, but two possible answers. If you try to use the 20 seconds, it's way too long. We're going to use the 7.81. So, back down to the page. Oops, sorry, my camera's getting hung up here. I'm going to get dizzy watching this video if I keep moving the camera around. Okay, so we have solved for y. Two different answers. 20.96 and 7.81 seconds. Now actually, I was wrong when I stated it. Sometimes in math class you get a negative answer for quadratic and you know it's impossible, and you get a positive answer. That's not always going to happen in physics. Sometimes you get two answers that could both possibly work until you think about them. This question, the balloon can't meet the elevator in under 15 seconds because the elevator hasn't even begun to rise yet. So it has to be 20.96 seconds. But here's what happens with these questions. Just like in two equations, two unknowns in math class, sometimes when you get an answer, it's not the answer to the actual question. We solved for y. And if you look back at the givens list, y is the time for the elevator. It's not the distance that the elevator rises. So just like in math class, you'll get an answer, and you have to take that answer and substitute it into one of your original two equations. The nicest equation of the two was x equals 6y was the equation for the elevator's motion. So let's just take that equation, use the value that we've now determined for y, multiply that out, and you'll have the final answer to the question. The elevator rises to a height of 126 meters. And I remember that answer from last year, so that's definitely right. Okay, you're probably really stressed out right now, but the reason why you're stressed out is not the physics or the way this question works out. What's stressing you out is the length of this solution and the messiness of the math. Let's do a way easier one so that you can see that complex mechanics doesn't necessarily mean that it's going to be a very difficult solution. This video is getting a little long, so I'm going to stop this video and start a new video, and we're going to do example number 2.